Okay, for the circuit shown below, calculate A. The total resistance of the circuit, B. The total current in the circuit, and then C. The potential difference across 4 ohm resistor. Okay, this one is about series and parallel resistor. Okay, it is almost similar to like the series and parallel capacitor that we learned before. Okay, maybe you can go back for a while and look at the capacitor. Yeah, like this one, series and parallel capacitor. Okay, this one. Right, capacitor. The flow of work is always the same. Like in capacitance, we learned that we need to find the total capacitance. After that, we got the total capacitance. We go to find the total voltage or total charge. And then in the end, we find the voltage or charge for individual capacitor. Yeah, V1, V2, V3, V4, Q1, Q2, Q3, Q4. We always start with finding the total first. In the end, only we go to the individual charge and voltage. Okay, so the same goes to this chapter, series and parallel resistor. We also start with, the flow of work. We also start with finding, finding the total resistance first, and then after that find the total current. This is the total current, and then in the end find the voltage of 4 ohm resistor, isn't it? We always start with finding the total first, total resistance and total current. In the end, only we find the voltage or current through each individual resistor. So the flow of work is always just like the capacitor. We always do find the total resistance, and then only we find the total voltage or total current, and in the end we find the each individual voltage, okay, or each individual current. Always like that, yeah. Always find the total, then only the last is this one lah. Okay, so never change. This rule is always the same, yeah. So I put beside here. Okay. All right. So now let us find the total resistance of the circuit. Okay, let us find the total resistance of the circuit. Question A. Total resistance. Okay, first of all, what we can see here, we have we also always do from branches first. Okay, we always do from branch, then only go to the main circuit. We always start with the branch, then only go to main circuit. So our branch is over here. This is our branch. Okay, and then our main circuit is this one lah. Okay, our main circuit. So let's start with the branch first. So all right, we can put this as maybe you can put label them. We can label them. This one as R1, this one as R2, this one as R3. Okay. So all right, we label already. So now let's do start with the branch, which is the 12 ohm and 4 ohm, R2 and R3. Okay, 12 ohm and this R2 and R3, they are parallel. Why they say parallel? Because both legs connected together. Yeah, you see, they have two legs connect to each other. Yeah, one leg from 12 ohm, another leg from 12 ohm also connect with 4 ohm. So 12 and 4 ohm, they are parallel to each other, side by side, yeah, connected side by side. Okay, so R2 and R3 first, they are parallel. Okay, so how to add up parallel resistor? How to total up parallel resistor? So you have learned about series and parallel resistor. Actually, resistor and capacitor, their formula is opposite. As I told you before, capacitor in parallel, they become stronger capacitor. Yeah, plus plus plus. Yeah, capacitor in parallel becomes stronger capacitor, the plus plus plus. But resistor in series, they become stronger resistor. Not stronger resistor, become higher resistance. Resistance in series become bigger resistance. Yeah, because the current have to pass through even more resistor, you see. So resistor in series become a bigger resistor. So resistor in series plus plus plus, but capacitor in parallel plus plus plus. You see that? Okay. So right now we using resistor. We focus only on resistor. So resistor in series plus plus plus, resistor in parallel become a smaller resistor. Yeah, resistor in parallel becomes smaller resistor. It is 1 over resistor. Okay, so this is a parallel resistor, so it's 1 over resistor. Yeah, 1 over resistor. Okay, so write it down. It is a 1 over R23. Yeah, we combine 2 and 3, so become R23. So it's 1 over R2 plus 1 over R3. Okay, and then resistor 2 is 12 ohm. Okay, write that down, 12 ohm, and then resistor 3 is 4 ohm. Okay, add up, they become it become 1 over 3. Okay, this is not the R23 yet. This is not the total resistance yet, because this is still 1 over R23. Understand? It's not R23 yet. So R23, so you need to invert R23. You need to invert this thing. It become 3. Yeah, 3 ohm. So R23 is 3 ohm. You see? Resistor in parallel become a smaller resistor. Yeah, 12 4 ohm, 12 ohm and 4 ohm, and then add up become a smaller resistor, 3 ohm. That's resistor in parallel. Now, okay, this R23 is in series with R1. Now we go to main circuit. R23 is in series with R1. Okay, so step 2, R1 and R23, they are in series. Why we say they are series? Because they only have one leg connected. You see that? They only have one leg connected between R1 and R23. So the other leg of R1 is connected to battery. It's not connected to R23. So R1 and R23, they are in series. Okay. So okay, in series, so series resistor, they plus together lah. Yeah, series resistor, they plus together. Okay, series become a higher resistance. So plus together. So we can say now this is the R total, or we want to write as R effective also can, yeah, or R equivalent. Yeah, as you like. Yeah, you want to write R total, or you want to write R23 or R equivalent also can. So it is equal to R1 plus R23. Yeah, series is plus together, become higher resistance. So R1 is 2 ohm plus R23 is 3 ohm. So total up is 5 ohm. Total up is 5 ohm. That's the total resistance. Okay, 5 ohm. Next is let's find the total current. Okay, now we go to we finish the step 1, find the total resistance. Now is finding the total voltage. Total voltage or total current, but we already have total voltage, right? This is the total voltage, 6 volt. 6 volt is the total voltage, so we can find the total current. Understand? So let's do the question B. Find the total current. Okay, so how to do this? It's very simple. Just use the formula Ohm's law. V equal to IR. V equal to IR. Like if capacitor, we also have the formula Q equal to CV, isn't it? Q equal to CV. So in this chapter, we're going to use V equal to IR instead of Q equal to CV. Okay. So we're going to use V equal to IR. And then because we are dealing with total, so all these are total value. we have total voltage, we have total, we need to find total current, we have total resistance, we got already total resistance from step 1. Okay, so let's find out what's the total voltage is 6 volt, and then want to find total current. Total resistance is 5 ohm. Okay, so my total current is 6 divided by 5. It is 1.2 ampere. It's 1.2 ampere. 1.2 ampere. Okay, that's the current. Okay, so we got the total current already. Now is going for the step 3. Step 3, we can find individual voltage and individual current already, but you must know the relationship, yeah, between series and parallel. Yeah, the V equal to IR can be applied there. Okay, let's do part C. Part C is to find the potential difference across 4 ohm. This voltage across 4 ohm is actually, we can write this as V3 lah. Can write this as V3 because it's resistance 3, yeah. Resistance 3, so it's V3, yeah. Okay, resistance 3 is V3. Okay, we want to find V3, so how to find? Okay, so from we have the total current. This can help us. Okay, can help us. Question C. Okay, question C, want to find V3, so how to find? Okay, what we know is this total current passing through all the resistors, isn't it? Yeah. Okay, this is the positive, negative. Okay, so the total current, this is the total current, will pass through all the resistors. Because this R1 and R23, they are in series. Okay, maybe I can write like this. R1 and R23, they are in series. Okay, if series means they have the same current. Okay, series circuit means they have the same current, current passing through all the resistors. So this R1 and R23, they are in series. So what I can say is the current I total is equal to current passing through R1, which is I1, and also equal to the current passing through the resistance 2 and 3. So I total equal to I1, the current passing through R1, and also equal to I23. I23, that means the current passing through the combination of resistance 2 and 3. So series means they have the same current. So this is equal to 1.2 ampere. 1.2 ampere. Okay. So and then we need to find only voltage 3. Yeah, voltage 3. So we need to so we're going to use this part. We're going to use this I23. This I23 will help us. I23, how is it going to help us? I23 can help us to find voltage 23. Can help us to find voltage 23. Because we also have resistance 23 already. So now we can find voltage 23. Use the formula V equal to IR. Okay, so this is the current 23, resistance 23. We can find the voltage across 2 and 3. V equal to IR all the way. See that? You see that? V equal to IR all the way. V equal to IR, and then V equal to IR all the way. Yeah, I just abuse this formula. V equal to IR. That's all. Okay. So V equal to IR. So voltage across 2 and 3 I can find. Later I can use the connection, parallel connection, and saying that V23 equal to voltage across resistance 2 and voltage across resistance 3. Equal voltage because they are parallel. That's how I do it. Okay, first you find voltage across 2, 3. Voltage across 2, 3. Why I find voltage across 2, 3? Because I already have the current 2, 3 and also resistance 2, 3. So I can find voltage 2, 3. This is the voltage 2, 3. has the closest relationship with voltage across tree. Understand? Always find something that is closer in relationship. Closer in relationship. So I can say voltage to tree has a closer relationship with voltage against tree. Voltage across tree. Okay? So that's why I find voltage to tree first. It has the closest relationship with voltage 3. Okay, V23 has the closest relationship with voltage 3. V23 with V3. Okay. So now let's do it. So we have the current to 3. Just substitute it. Just substitute 1.2 ampere in current to 3. Resistance to 3 is 3 ohm. 3 ohm. So we have 3.6 volt. So voltage to 3 is 3.6 volt. Okay. And then we can say that these resistance 2 and resistance 3, they are parallel. Resistance 2 and resistance 3, they are parallel. Back to parallel relationship. So what can you say about this parallel relationship between 2 and 3? We can say that this voltage to 3 is the total voltage between 2 and 3. And we can say because they are parallel, resistance 2 and resistance 3, they are parallel. Parallel resistor have the same voltage. Same voltage. Yeah, they have the same voltage. V total equal to V1 equal to V2 equal to V3 because they are connected to the same point. You see that? So they have the same voltage. If series, they have the same current. If series, they have the same current. Okay, same current. Series, they have the same current. If parallel, they have the same voltage. Parallel, they have the same voltage. Alright, so right now 2 and 3, they are parallel, means they have the same voltage with the V23. So I can say that V23, the total voltage between 2 and 3, is equal to voltage across 2 and also equal to voltage across 3. Equal to voltage 2 and equal to voltage 3 because they are parallel. Parallel have the same voltage. Okay. So, and it is equal to V23, just now we got it, 3.6 volt, 3.6 volt, and what I want to find? I want to find V3. I think I got a V3 already. So V3, this is the V3. So V3 is 3.6 volt because it is equal to V23. Okay, so I think got all the answer. Am I right? So check the first answer, A. A is 5 ohm, that's correct. And B, the total current is 1.2 ampere, that's correct also. And C, the potential difference across 4 ohm. Potential difference across 4 ohm is V3. V3 is 3.6 volt. 3.6 volt, 3.6 volt. That's correct also. So that's that's my strategy of solving series and parallel resistor. Almost the same strategy to do series and parallel capacitor. Just that right now I use V equal to IR instead of Q equal to CV. Alright. Right, I use Ohm's law, V equal to IR instead of Q equal to CV. This one is for capacitor. Okay, so that's all for these questions. See you in the next video. Bye bye.